Hello, this section is about modulation and demodulation. We will first explain what is modulation, and then we'll try to introduce three modulation approaches: amplitude modulation, frequency modulation, and phase modulation. Local loop, trunks, and switch offices are three main components of telephone system. Local loop is the part connecting houses or business to telecom company's device. Telephone line is the transmission media used in local loop, which is unshielded wine. Transmission lines suffer from three major problems, especially for unshielded wines. The three problems are attenuation, delay distortion, and noise. What kind of signal is transmitted on local loop? Is it digital signal or analog signal? As we know, computer can only process binary digital signals, which are zeros and ones. Binary digital signal can be easily represented by square waves. It seems to be a good choice to simply use square wave on local loop. However, the square wave used in digital signal have a wide frequency spectrum, usually high frequency, and thus are subject to strong attenuation and delay distortion. Hence, we actually transmit analog signal on local loop. If we look at the diagram of use of telephone system, for a computer-to-computer call, we actually need both analog and digital transmissions. As we use analog signal on local loop, and the computers only process and generate digital signal. Therefore, we need to do conversion between analog signal and digital signal. Modem and the codec are the devices doing this conversion job. Modem is a combination of modulator and demodulator. A modem is a device that modulates outgoing digital signals to analog signal. The modulation is introduced to do the conversion. There are three modulation approaches. Amplitude modulation, AM. It uses two different amplitudes to represent 1 and 0. That is using high amplitudes of an analog signal to represent 1 and the low amplitude signal for 0. Frequency modulation, FM. It uses two different tones to represent for 1 and 0. That is high frequency for 1 and low frequency for 0. Phase modulation, PM. It uses different phases or the change of phases to represent digital information. For example, the waves can be systematically shifted to different phases: 45 degree, 135 degree, 225 degree, or 315 degree. For a bit stream listed on the top of the diagram, the square waves are displayed in diagram A using voltage levels to represent 1 and 0. If we use amplitude modulation to transmit the above bits, we can use high amplitude for 1 and idle, which is the low amplitude for 0. As displayed in the diagram, when frequency modulation is used, we can use two different frequencies, high frequency for 1 and the low frequency for 0. If phase modulation is used, we can use the change of two adjacent signals to represent either 1 or 0. In this example, if the two phases are the same, it represents 1, and if the change of phase is 180 degrees, it is 0. Modems can support conversions in both directions. A connection that allows traffic in both directions simultaneously is called 4-duplex. The 4-duplex connection example can be the telephone call. A connection that allows traffic either way, but only one way at a time, is called half-duplex. Walkie-talkie is an example of half duplex. A connection that allows traffic only one way is called a simplex. Two simplex connections can make up a full duplex connection. Modulation is about to use analog signal to represent binary data. Therefore, logically, there are two types of things being transmitted: analog signals and binary bits. So we are going to talk about the data rate and the signal rate. Data element is bit, which is a signal binary 1 or 0. Data rate is bits per second. It is the rate at which data element can be transmitted. Signal element is single signal or symbol. Signal rate or modulation rate is the signal elements per second, also called as baud. It is the rate at which signal elements are transmitted. In the end of this section, we have two questions for you to think about. We just explained the data rate and the signal rate. Question 1, numerically, does data rate equal to signal rate? Question 2, please draw the diagrams of AM, FM, and PM for the digital signal 00101000. It is end of this section. Thank you very much.